So time to use another substitution. Here we need to evaluate the following integral. It's indefinite integral, so we don't have to worry about boundaries and such. Dx over x squared times the radical, the square root of x squared plus 4. Okay. Can you right off the bat tell me what would be the substitution in this case? The tangent, precisely what? What is the value of A? So x will be 2 tangent theta, and we need to produce dx. Dx will be the derivative of the tangent, folks, is, come on, secant squared. Yes, this need to be automatic. At this stage, this sort of thing is, you're not supposed to go and look for it. You need to get it right away. All right, now we need to evaluate. Let's evaluate the denominator, okay? Let's see what happened with the denominator. So we're looking at the x squared times the square root of x squared plus 4. Well, x squared will be 4 tangent squared. And the square root of 4 tangent squared plus 4, of course, factor out the 4, the square root of 4 is 2, so you end up having 8 tangent squared. And here we have the square root of tangent squared plus 1, which equals to what? Secant squared. So we end up having 8 tangent squared secant theta. Do tell me why 16. You have, I'm factoring square root of 4. Okay, so now time to incorporate the dx. So let's say I is the integrals. So we'll repeat it one time. We have dx over x squared, square root of x squared plus 4. It's the integral of dx is 2 secant squared d theta. And the denominator is 8 tangent squared secant. All right, so we have 1/4 integral, and let's see, we have secant over tangent squared, right? Now, if I had secant squared over tangent squared, then I'm good, because secant squared is the derivative of tangent, but I don't have the secant squared, I have just a secant. So I'm thinking, you know what, I'm going to express everything in terms of sine, cosine, see what happened. So that will be the next step. I'm going to say that this is 1/4. Hopefully you're not choking over there. You okay? Good. So I don't have to do the Heimlich maneuver on you or anything like that. All right. So let's look. The secant is 1 over cosine, right? Now 1 over the tangent is the cotangent, right? The tangent in the denominator is cotangent in the numerator, and the cotangent is cosine over sine, but we have the tangent squared, so we have cosine squared over sine squared. And here's the advantage. I end up having cosine theta d theta in the numerator, and I have sine squared in the denominator. This is wonderful because cosine theta d theta is a differential, or if u is sine theta, du dx will be cosine x. So actually I should say du d theta. So if we do u equal sine theta, then du equals cosine theta d theta, and now the integral is 1/4 integral of du over u squared. Okay? So the antiderivative will be what? Negative 1 over u, right? U to negative 2, add 1 and divide by. So it will be negative 1 over u plus c. Now I need to start the process of back substituting, right? Remember, at the end of the day, I need to come up with x. So first, I'll write, in terms of u, in terms of the sine, u equals sine theta, so I'll have negative 1 over 4 sine theta plus c. But I'm not out of the woods yet. I need now to express everything in terms of x. Go back to the original substitution and say x equals 2 tangent theta. So tangent theta equals x over 2. I need an expression for sine theta. Again, I can use trig identities to express the tangent in terms of the sine. It's a little bit inconvenient because I have sine over cosine. Now I need to express the cosine in terms of the sine in terms of x. It's much more elegant to use the right triangle substitution. Okay? The tangent opposite over adjacent, so x over 2, and of course the hypotenuse will be the square root of x squared plus 2 squared, or x squared plus 4. Notice that we obtain back the radical. That's the theme here. Okay, now I need the sine. So from here I get sine theta equal the opposite over hypotenuse, so it will be x over x squared plus the square root of x squared plus 4, and now the integral is negative 1 over 4, so it will be, flip this over, and you have the square root of x squared plus 4 divided by 4x plus c. Good? Somebody said it's crazy?